You must have heard of the rock, paper, scissors game. And it's not just children who play it. Adults play it too, when they cannot agree on something and would rather leave the decision to chance or luck, like tossing a coin. A Florida judge once ordered two attorneys to play it when they could not agree on where to hold a deposition. The rules are simple, the original rules. The players hold their right hands out simultaneously to represent a rock, a piece of paper, or a pair of scissors. A rock is represented by a closed fist, a paper by an open palm, and a pair of scissors as the first and second finger held apart. Rock wins over scissors, maybe because it can blunt or smash it. Paper wins over rock because it can wrap over the rock. And scissors wins over paper because it can cut paper. And if the two symbols are the same, it's a draw. So, can we analyze this game using our game theory concepts? Let's try. And here it is, the payoff matrix. P1 is player 1 and P2 is player 2. The payoffs are written as payoff for player 1 first, then a comma, then the payoff for player 2. +1 is the payoff for a win, 0 for a draw, and -1 for a loss. If both play the same, then it's a draw, so the payoff is 0, 0. Those are the diagonals of yellow cells. Paper beats rock, as you can see in the blue cells. Rock beats scissors, as you can see from the green cells. And finally, scissors beats paper, as you can see from the pink or peach colored cells. Now, if you take the payoffs for any player, P1 or P2, across any row or column, it will be 0. For example, for player 1, the first row of rock, the one highlighted in yellow, has payoffs 0, 0, -1, 1, and 1, -1. That's a net of 0 across the row for player 1 and player 2. There seems to be no single winning strategy overall. Every strategy has the same net payoff of 0. The Nash equilibrium can therefore be a 1/3 split between playing rock, paper, and scissors equally. It can also be playing rock all the time, for example, because the payoffs would be the same as long as someone does not predict your strategy. The average payoff over a large number of plays will be 0. This is called a mixed strategy Nash equilibrium, where multiple strategies can be winners or there may be no single winner.